No niin, hyvää iltapäivää. Good afternoon, everyone. Thank you for coming here at the University of Helsinki Department of Archaeology. We have a very special guest here this afternoon from Norway, Arne Andersson Stamnes, who is a geophysicist from Norway, specialized in archaeological prospection. And we have a pleasure of having him here. He has been spending a couple of days already in the field with Vesa Perttola, our university instructor. And they have been trying to do some GPR scanning in an Iron Age landscape near the city of Karjaa in Raasepori. But the weather conditions have been quite challenging at the moment. But Arne has now come here to Helsinki to give a lecture about archaeological geophysics in Norwegian Cultural Heritage Management and its possibilities and limitations. So welcome, Arne.
Thank you. I'm gonna sit down mainly, I think, and then stand up and point every once in a while. If you have any questions, just feel free to jump in at any time. My background is in archaeology. I'm an archaeologist by training. I did initially a master's on predictive modeling of Iron Age settlements. Done a fair bit of fieldwork, and then I decided to go to England to study something called archaeological prospection, which is a specialized course that was taught at the University of Bradford on using various prospection methods, not only geophysics. Of course, much of it was focused on geophysics, but it could be soil prospection or analysis of various soil properties, such as, I don't know, phosphates. I do know it's phosphates or magnetic measurements or other chemical properties of soils that you can measure to try and use it on archaeology, basically. I then proceeded to do a PhD in Trondheim, looking at the way archaeological geophysics has been understood by my colleagues within Norwegian archaeology. It was basically both an analysis of how geophysics perceived and is understood by my colleagues, but also and in public documents and things like this, its applicability, its limitations, and its status and role within Norwegian archaeology. And I'm going to come back to that a bit with a few slides. But it was also testing various geophysical methods on different types of sites, including settlement sites, burial sites, medieval churches, iron production sites, and things like this. All right. What are geophysical methods? I'm not going to go into detail on explaining each and every method, but if it comes up, I might mention it. And then of course, if you want to know more about it, just feel free to ask. But it's definition, or is defined by Chris Gaffney and John Gager in their book from 2003 as the examination of the Earth's physical properties using non-invasive ground survey techniques to reveal buried archaeological features, sites, and landscapes. So we're looking at both features, the understanding of complete sites, but also the use of geophysical techniques on entire landscapes. For us, usually it's things that go deep and look into the ground. That's what we try and explain it. We have different stuff that can do different things, all ranging from like single channel radars to hand-carried magnetometer systems to measurement of electrical properties. That's also an electrical method. Fancy radar systems. This is a Swedish MALO system that the Ludwig Boltzmann Institute and the Norwegian Institute for Cultural Heritage Research uses. That's the radar that we currently have, and this is what we're putting on our UTV at the moment, the belts, and hopefully you won't get stuck in that kind of slightly thawed field. And this thing is EMI, or electromagnetic induction, where you can measure both magnetic and electrical properties at the same time. Often it's mainly characterized as three different methods, either measurements of electrical properties, magnetic properties, or electromagnetic properties. Like, yeah, it's kind of diffuse, but both these are considered electromagnetic techniques, where you measure a radar, for instance, sends signal into the ground, and it measures how much of that signal, a radio signal, is transmitted back to you, and how long it takes. And by having that time, you can also judge roughly how deep it is. So you then make maps of the reflections throughout the ground. Then I go into the geophysics in Norway a bit for a little while. And then I'm going to go and present some case studies of various nice finds and ways that geophysics has been used. But for the heritage management in Norway is built up as such that you have a directorate that has the overarching national responsibility. They're under the Ministry of Environment, actually. Then you have 5 regional archaeological museums that they do all the excavations in their part of the country. Archaeology is not privatized. And if, let's say, a developer wants to develop a piece of land, it goes to the county authorities. They then do the site evaluations and the registrations. They treat the planning permissions, and they do the management of it all. And now the authority to decide whether or not something would be exempt to the Cultural Heritage Act. Like all sites, everything older than 1537 has an automatic protection, whether or not it's been discovered or not. So if it's still there, you don't know it's there, it still has a legal protection. And therefore, when it's discovered as part of a planning process, earlier it was these guys who decided whether or not you were allowed to excavate it. Now that authority has been moved down to the counties. So it's a slight change. That started this year, so you don't really know how it's going to act out. It's going to be an interesting year. The main benefits of geophysical methods, as we as practitioners see them, is that they're non-intrusive. You can gain more knowledge in a non-intrusive manner. It can be quite quick when the ground's not bad. And also you get very high spatial accuracy and quite a high detail of features on the ground. And this then can be used within planning of excavations and future archaeological surveys, the management of the site, and then also site characterization, so you can learn more and then use it for archaeological studies, research projects and things like this. If you look at the public documents within the Norwegian Cultural Heritage Management, these are the things they're mostly interested in using geophysics for. Some of the same things go back: mapping of archaeology, a tool for better management and development plans, to prioritization, budgets and rationalization, precision, limiting conflict between developments, and then I think these are in from what they mentioned the most to what they mentioned the least, but still mentioned a bit. And then so they're more interested in this bit than actually cultural heritage, cultural historical knowledge and preservation, interestingly enough. When you look at the development in the use of geophysical techniques in Norway, this just goes back to 2000. The earliest ones were all the way back in 1958 or something, and there was almost nothing happening. A few surveys in the 90s, and then things started to happen around this time. Most of this was one survey, one big project that did some magnetic surveys for finding Iron Age settlement sites. And then something really interesting happens around from 2010 to 2011. And the reason for this very high increase is twofold. One is the NICU, which is Norwegian Institute for Cultural Heritage Research, together with Vestfold County Council entered a collaborational project with Ludwig Boltzmann Institute in Vienna, and then did a lot of really large-scale, very high precision, extremely good stuff with fantastic results. And then I started my PhD, basically. And them, NICU and us, were the only ones doing archaeological geophysics in Norway at that time. And there's quite a lot of research going on, and at a certain point we can see that the research projects, they dip, and the use in management start to increase. So basically we see that by doing some years with very targeted research, it changes somewhat the attitude in the management, and we see that the amount of surveys we do for management purposes increases tenfold. And if we were to continue this, I don't have numbers for the last couple of years, it's going straight up. What we also see is that the sizes of the land, of the areas that we go in, increase quite immensely. And so while we were kind of doing maybe these are quite small surveys, and some of the things I did for my master's was quite small, or my PhD was quite small in area, it now increases. The latest thing that just came out this year is that someone had a tender out for a 150 hectare survey, and that's quite a bit of land to cover. The reasons for, you can say, a lack of acceptance is that some of the earlier things had a kind of a low resolution, and kind of there was technical limitations in the software and also in the equipment. It was oversold sometimes or overinterpreted. It's about what I call over-optimism, and that has created kind of an idea that geophysics don't work because we did it in the 90s and didn't work then, why should it work now? Norway is full of, what you call igneous and metamorphic rocks, magnetic stuff, have been turned more magnetic by high temperatures and pressure and things like this, and that creates a lot of ephemeral random rocks lying about that might act, especially from a magnetic point of view, similar to a cooking pit, for instance, or a hearth or something like that. So it can be, in certain methods, difficult to distinguish a big stone from, let's say, an iron furnace or something like that. I'll show you some examples later on. Our Iron Age settlement sites are often distinguished by cooking pits and post holes. A post hole 35 to 50 centimeter, sometimes not backfilled with anything very distinguishable from its surrounding soil. It varies a bit. Sometimes you have burn posts that's put, and then there you can see the traces of the burning. Sometimes they put stones in to kind of keep the post hole in place, but they're quite small. And that means that they're also quite difficult to find because they don't necessarily have a geophysical contrast that we can detect. And last but not least, there's been a definite lack of trained personnel and people that has learned to do this, but that also has an understanding of the archaeology or how to ask archaeological questions. In my opinion, you shouldn't just go out and do it because it's cool, but you should have some form of aim and objective in mind why you should do it. What's the reason why you choose these methods instead of something else to solve your problems. Of course, if you go back to like the arguments for why you should use geophysics, of course, the non-intrusive bit is the most interesting. You can learn a lot without ruining anything, and it's repeatable. You can go back, you can survey it again with different equipment or other stuff. So the current status of acceptance, it could possibly revise this slightly, but this was most of this was at least the status in the end of 2016 that there's still a skepticism, and it's been a slow implementation. If you look at the total amount of site evaluation, let's say test trenching and things like that's been done versus the amount of those type of projects where geophysics plays a part. I think in 2016, geophysics was only involved in about 2% of all the work done in Norwegian archaeology. There's a lack of resources and possibilities to integrate those resources in there, and there's just very few institutions. Now there's 3, the University of Stavanger, NICU and us at NTNU in Trondheim, that has at least some geophysical equipment. Most of the geophysical equipment we have now is now in a house in Fiskars, but there's a need for increased knowledge, and that means some good projects where you can demonstrate some form of applicability, or the lack of applicability, if that's where you end up. But also to be able to use these kinds of methods in a fruitful way, it's also important that the decision-making bodies, Ministry of Culture or whatever, the National Ministry of Cultural Heritage, I don't know what it's called in Finland, but those guys, whoever it is that decides how things should be done or might be done or what to do with the cultural heritage sites, they also need knowledge to say, well, I see your point here, but have you thought about maybe using this instead? And then you don't have to destroy that much. But since 2013, we noticed an increased interest and definitely an increased workload and a change in attitudes. More and more colleagues come to us and think that this is a good idea. The reason for that is you can see the investment in equipment at NICU and NTNU and also Stavanger now. An increased amount of publication of articles, reports, and media appearances. I think if you count the total number of published articles, and at least half of them is peer-reviewed, maybe more. Some are like Popular Archaeological, but at least 50 articles now with examples of geophysics in Norwegian archaeology. I have a graph somewhere. You have some really groundbreaking archaeological discoveries, so we're starting to see examples of really good archaeological finds in the data that we didn't see before. And also the major developers, let's say the Norwegian Public Roads Administration, Bane NOR roads, and also some other archaeological museums are starting to gain interest in this. And actually the big developers like the roadworks and the railroads, for them, let's say chipping in 200,000 euro in a project is nothing compared to the budgets they're working on. And if they can do that to at least appear more like forthcoming, it has value to them outside of do what they're supposed to do, but it also shows that they care about the heritage and they want to include it as early as possible. So, and also they can develop an earlier and more fruitful collaboration with ground owners, because then you can, to a certain degree, evaluate if there's any conflict on their land without ruining the crops or digging up the ground. So for them it has value outside of just what they're obligated to do, and they don't mind paying for that, you could claim. Also the results from geophysical surveys have value outside of archaeology as such, and I'll come back to that later on, but I can mention it quickly, and that is like for geological mapping, drainage, ditches, and all these things that often is poorly mapped, or you don't know where you put exactly where you put the ditch last year. You have a map maybe, but that was just someone drawing a line. Things like this. I'll come back to that. But the consequences of, you could say, kind of the somewhat a bit lack of the usage of geophysical method, if you want to talk about that, you can say, I said political versus knowledge-based management, that decisions comes from top down or not from necessarily researchers that can have their say. There's been a slow implementation on conventions, treaties and strategies, and that's interesting. For the Valletta Convention, for instance, says that you should use non-intrusive methods whenever possible, and that's a convention that we've signed, that we in Norway at least are supposed to aim for as the goal. And then you can discuss what is meant by non-intrusiveness, and this is written before people started to talk about preventive archaeology and such. I think it's mainly written to kind of enhance the developer pays principle. Treaties, there's the ICOMOS treaty and things like this that also mention the use of non-intrusive methods. So this is something we've said we should do, but don't necessarily do. And I would say that there's less focus on the values of preservation, knowledge, identity of cultural heritage management, and there's more focus on holding costs down and avoid negative press. So the value of the heritage itself and its meaning to the locals is kind of hold down a bit, and a lot of the management people often just want to kind of hold the costs down so it's not too. So it was our responsibility as such, and sustainable management, loss and damage. That So a consequence of that, like I say, a slow implementation of non-intrusive methods is that you lose more sites basically. So some results, some of these are mine, some of these are borrowed from other institutions. This one and some others are from the Norwegian Institute for Cultural Heritage Research, NICU. They do kind of the same thing as us with belts, and we can get really good results in wintertime, when we do have ice and snow. And this is an example from a mountainous area where there was should have been a church, and they found it. It's this rectangle here. This is just one depth slice, and when you scroll up and down into the ground, you get a new image like that for every depth. And this is just one particular depth, and an interpretation of what they found with the walls and then the church foundation and all that. This is a survey that we did in Løkja in Sunndal. This is the 3D radar, ground penetrating radar we have. That has an A channel every 7.5 centimeter, which means that you get a section through the ground at every 7.5 centimeters, and we can take out a section in whatever direction we want in the software. So I have an animation. I also have the entire data set with me, so we can have a look later on. But this is kind of how it looks. You start from the top, and then you scroll down, further down into the ground. And now we're in kind of the plow soil. You see some of the stripes, then you see a lot of pits popping up. All these black dots. You have a burial mound over there, you have a house over there, and it really gave, see that ridiculous amount of stuff going on. This is, I must admit, the best data set we've ever collected. So this is like the prime time viewing here. So if we can just stop it there, for instance, you can see all of these pits. They're probably cooking pits because the county stuck a trench in there over some of these, and we know that are pits. But we also see some really large ones. Some of the, not all of our burial mounds, but quite a few had a ring ditch around them. So that's a good giveaway. Let's see if I can scroll We have an Iron Age longhouse over in the corner over there. There we go. These posts are about 25-30 centimeters, and then you have parallel roof-bearing posts and the wall posts around. So that is like 25 times 5 meters. So all in all, we had 11,500 of these pits. We had a house there, there's another house over there, and I believe that this area, which has a lot of stuff going on inside, actually so much that we couldn't distinguish everything. Like see all the small little white specks there, they could be archaeological, but in the end we didn't have time to draw all of them. So this really gave really tremendous results, and the reason why we did geophysics at this spot was that there was a lot of private individuals who'd done a fair bit of metal detecting and found quite a lot of interesting objects. So wherever we are in this data set, we can go in, and I can demonstrate straight away actually. These are the spots for the metal detecting finds. Then each of these lines, let's see if we can select one of them, is one of our passes with the radar. Why isn't it selected? And that's one pass with the radar. Interesting. Supposed to be more data. Okay, it's loading from my external hard drive. So this is like the width of the antenna, and you can then see the section. You can double click on it, and then you get the feature. So you can, and that image is supposed to change. It probably will in a minute, and you can see more there. So my external hard drive is running.
Sorry, what was the antenna?
The antenna here.
Yes.
It's a step frequency ground penetrating radar. So it transmits everything from 50 to 3,000 megahertz. A standard ground penetrating radar antenna has a center frequency, and then it transmits a range of, so we can, if the center frequency is, let's say, 400 megahertz, it can send down to maybe 200-300 megahertz and up to around 800, sometimes more, sometimes less. This one sends at one frequency, then jumps to ups to the next, sends on that for a while, and then continues on. So it gives a good impression at all depths with the most applicable frequency at that depth, and then you can adjust in the software. Actually, I see now that this is a stitch. A stitch is the entire data set put together in one big block. So wherever you want to be in this data set, I can double click on it and we'll jump to it, and then you actually have this is a profile in that direction, and that's a profile in the other direction. So you can spend a lot of time just characterizing, looking, interpreting, trying to understand what type of archaeology this is. Which also means that if you go up to our lovely little house over here, you know, it looks quite good there, right? And then you can double click there, and then you have all the roof-bearing posts, and this is how it looks in that data set. So that is a cross-section through all the the wall-bearing posts of that house. So that's, the software for this is quite magnificent because it's so interactive. But also the amount of data you can get out is just a matter of how much time you've got sometimes, and then you have to set the limit somewhere. So this is all that we found. 2 houses. I believe that this area had a lot of stuff going on. This was actually not a ditch, but we could see like compressed soils outside of it, and the county stuck a trench in there, and this is actually a burial in the middle. They found a brooch in there from the, I think it was Roman or migration period, Roman Iron Age or migration period. Also, a lot of you have those clusters, which is interesting. And one way of interpreting a site with so many pits is that it's some form of predecessor of a gathering site, a thing site, you can call them if you want. And this is the largest one found north of that mountain chain, Dovre, and it's one of the only ones that we have from the central part of Norway. There's a couple of others that has Lund in Vestfold, for instance, which has about 1,000 pits, and there's a couple of others known that has 500-600. This one has at least 1,150. I guess if you use more time, you'll find more. Yeah. So, just an example with the ditch around it, and that's cross section. So you have that ditch there, and then you can't really see it on that side, and then you have some form of pit in the middle, another pit there, and another pit there. So it's quite a massive tool, and hopefully tomorrow we'll get some data like this from Kaja. Okay. Viking ships, that's the new cool thing. That's these two was not found by us. This one from Gjellestad, where you can see some drainage ditches as cuts through, and what they did to try and evaluate what they found was that they opened up, they knew where the ditch was, they knew there was a ditch there, and they had already ruined part of the ship, so they can empty that ditch and then prevent destroying any of the other artifacts or the preservation conditions. To design a project that will maintain and keep the preservation conditions as best as possible. This is another one. This is the Gjellestad ship, and there's a couple of videos here, and I thought I'd show you that, and I can start with the. I'm not connected to internet. I didn't think that's far. Is there a room? Action required.
Great one.
And I think you don't need to. I can.
The camera is blocking out. I have to restart.
Okay. Good timing.
Just a moment.
See if I'm able to. There we go.